Alright, so today's lesson is on mean absolute deviation. We're going to talk about using it to compare two sets of data. Mean absolute deviation is something you've done in the past, but we're going to go ahead and review it first. It is a numerical measure of spread that shows how much data values vary from the mean. A low MAD, or mean absolute deviation, indicates the data points tend to be very close to the mean, so the mean is an accurate description of typical. A high means absolute deviation indicates that the data points are spread out over a large range of values. Okay? So the lower the number, the closer my data points are to the mean. The higher the number, the more spread out the numbers are and farther away they are apart from the mean or the average. So steps to go ahead and find your mean absolute deviation. First one is we're going to go ahead and find the mean of the data. Then we're going to go ahead and subtract the mean from each data point. We're going to go ahead and get the absolute value of each of those differences. And then we're going to go ahead and find the mean by those values from step 3. Also next to here you can see there is how to use your TI-73 calculator to go ahead and solve it. We're not going to do that in this lesson today, but we may do it in class. So my first example, we have find the MAD of each of the data sets. So first one I'm going to look at is hours spent on homework. I have 1, 1, 1, 2, 2, 3, 3, 3, 3, 4, 4, 5, 5, 5, and 7. So my first step is going to be for me to go ahead and find the mean of the data. Okay. So it's best for you to go ahead and create a chart here. Let's go ahead and see if we can include both of these. Okay. So when I create my chart here, I label at the top here I have hours of homework, and I listed out all of them. And so to find my mean, I'm going to go ahead and add them all up, and I ended up getting a mean of 3.27. Alright, the next step is I'm going to go ahead and subtract the mean from each data point, and then I'm also going to get the absolute value of each of those differences. I'm just going to go ahead and do the absolute difference, meaning I'm going to take my mean and I'm going to subtract it from my data point. So I'm just going to always do the larger number before, so 3.27 minus 1 is 2.27. And that goes the same for the next two, so 2.27. Then I have the difference of 3.27, my mean, and my two data points of 2 is going to be 1.27. So I have two of those. The difference of 3.27 and 3 is going to be 0.27. And there's 4 of those. Then the difference of 3.27 and 4 is 0.73, and there's 2 of those. And the difference of 3.27 and 5 is going to be 1.73, 1.73, and 1.73. Got 3 of those, and the difference of 3.2 3.73. So when I go ahead and add all of those up right there, I actually get an answer of 20.85, which I went ahead and did ahead of time. So I would use my calculator to go ahead and do that. So now that I've found my total here, I can go ahead and divide it by the total number of data points, and that's what I'm going to do is I'm going to find my mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to do 20.85 divided by 15. And I get an answer of 1.39. Okay? So my average, my mean for this data set is 3.27. Okay? The mean absolute deviation is 1.39. So on average, a data point is about 1.39 away from this average right here. Alright, so my next one is hours spent watching TV. So we're going to go ahead and do the same thing for that one. Go ahead and see if we can get everything in here. Okay. So I went ahead and listed them out all ahead of time as well. I have 1, 2, 3, 3, 4, 4, 4, 5, 6, 6, 7, 7, 8, and 9, 9. And I went ahead and totaled them all up, and I got an average of 5.2. So I'm going to go ahead and mark that on my sheet as well. My mean is equal to 5.2. Alright, And then my absolute difference I need to go ahead and find. So I'm going to find the difference between my actual data point and my average. And I'm just going to take the absolute value, so it's always going to be positive. So 4.2, then I get 3.2, 2.2 twice here. 5.2 minus 4 is 1.2. I'll do that 3 times. 5.2 minus 5 is 0.2. 5.2 minus 6 is negative 0.8, or the absolute value would be 0.8. I have to do that twice. The difference between 7 and 5.2 is 1.8. That twice. Difference between 5.2 and 8 is 2.8. And then 9 would be 3.8 twice. So I went ahead and added all of those up. So I'm going to find the average of this absolute value difference. So I added them all up to get 31.12. And I'm going to do 31.12 divided by 15, because there's 15 points of data. And I get 2.08. Come over here and fill this in. Alright. So now if I look at my question here, it says, what does the MAD tell you about each data set? So one, we have hours spent on homework. We have an average of 3.2. And then we have hours spent on TV, 5.2. And then the mean absolute deviation there as well. Okay. So what does it tell us about each set of data? We can say that, let's say on average, more time is spent watching TV. Okay, so that's our mean, kind of a comparison. Then we can compare our the absolute deviations, and we notice that the 1.39 is smaller than 2.08, so we can say time spent on homework we'll say has a smaller variability, meaning the numbers don't change as much. There's not as big of a difference in them. Okay, we can say that watching TV has a larger variability because the numbers are a little bit more spread out and more different. Our hours spent on homework are going to be clustered together more. Okay. All right, so number 2, we have find the mean absolute deviation for each of the data points. The first one we're going to look at is George's points per game, and then we're also going to look at Nate's points per game. So let's go ahead and do George's first. Let's see. Went ahead and did it a little bit ahead of time here. So we have George's points are all written out for you here. And I went ahead and found the average to be 27.3. I added them all up and then divided by 9, because there's 9 sets of data points there. And then now I'm going to find my absolute difference. So I'm going to go ahead and subtract 27.3 from each of these. Okay, and it's the absolute value, so it is the positive. So 4.3 we get 2.3 twice. We get 0.3. We get 0.7 twice for my 28. 1.7 for my 29. 2.7 and 3.7. Okay. Go ahead and add all these up. You should get 18.63. Then to find the mean absolute deviation, I'm going to go ahead and do 18.63 divided by 9. And I get an answer of 2.07. So I'm going to go ahead and fill that in on my chart over here first. George's points, I'm going to mean equal 27.3, and his deviation there's 2.07. Alright, let's go ahead and do the same thing for Nate's point per game. Alright. So I have all of Nate's points here, and I went ahead and added them all up and got 28.3. So I'm going to go ahead and use that to find my, fill this in, average and then my absolute difference. Okay. Let's go ahead and find the absolute difference of these. I'll go ahead and get a 10.3. This one is a 5.7. Right. Nope. Should be, sorry, 4.3, 3.3, 2.3 for 26, 0.3 for 28, 1.7 for 30. Should have 3.7 for 32, 5.7 for 34, and a, let's see, 7. Oops. 9.7 for my 38. Go ahead and add all these up and I should get a total of 41.31. So I'm going to go ahead and use that total to find my the mean absolute deviation. So 41.31 divided by my 9. Get an answer of 4.59. So I'm going to go ahead and include that then, my totals here. So my average we said was 28.3, and then my mean absolute deviation 4.59. So I can go ahead and now use this information to answer my question. What does the MAD tell you about each data set? Alright, what my MAD does tell me about each data set is that George has a lower mean, a lower average by 1 point, but George also has a smaller mean absolute deviation, which means he's going to go ahead and score around his average more often. Nate has a higher average deviation, which means he's not always going to score around his average. Sometimes he's going to be a little farther above, and sometimes he's going to be a little farther below. So George is going to be more consistent, while Nate is going to have a wider range, a larger variability. Okay, so we'll say Nate's MAD shows that he has a wider variability. Okay, so Nate is not consistent, even though he does average a little bit higher, but he's not as consistent as George. Okay. Alright, so what I want to go ahead and do right now is pause your video, and I want you to try what we just did with Sally's earnings versus Jane's earnings. Okay, so go ahead and copy each list, go ahead and find the mean of each one, and go ahead and find the difference of the mean in your data points, and then you can go ahead and find the average of that difference as well. Hopefully you've paused your video. Okay, we'll go ahead and take a look, and hopefully what you get. Let's go ahead and pull this out a little bit. Alright, hopefully you should be getting. Alright, so Sally earned in 1 week. You should have gotten an answer. You should have gotten an average of 139. Okay, and then we also then should have seen a let's go and do this mean of 139. So she would have a mean deviation of 12, and then we had Jane's average was 129.3, and then she has a mean average deviation of 12.6. Okay. Alright, and so what does the MAD tell us about each data set? Well, if we look at this, we know that on average that Sally's definitely going to make more than Jane does. And we can also see that Sally is more consistent in her earnings. Both of these are pretty high mean deviations, but we do see that Sally's is a little bit less than that one. So we can say that, I would go ahead and write about absolute deviations. I would say both are similar, but Sally's lower, showing more consistency or less variability. Okay. So that is our lesson for today.